Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad IQBAL bin DARWIS. My matric number is 1202374. Okay, today I will be presenting about future value. Let's see what is future value. Future value refers to the amount an investment is worth after one or more period. Suppose you invest $100 in a saving account that pay 10% interest per year. How much will you have in 1 year? In general, if you invest for one period at an interest rate of R, your investment will grow to 1 plus R per dollar invested. R equal to 10%. 1 plus 0.10 equal to $1.1 per dollar invested. $100 times by 1.1 equal to $110. Now let's see future value formula. Is S equal to P1 plus R, and S is accumulated amount after n period, P is principal, R is nominal interest rate per year, and N is time period. Now is future value general formula. Okay, we can see the future value of $1 invested for n period at a rate of R per period is this. Okay, we can see at the slide, the expression 1 plus R N is sometimes called the future value interest factor. Okay, going back to our $100 investment, what will we have after 5 years? Assuming the interest rate does not change. Okay, 1 plus R N equal to 1 plus 0.10 power of 5 equal 1.1 power of 5 equal to 1.6105. Okay, our $100 will thus grow to $100 times by 1.6105, so equal to $161.05. Now let's see investing for more than one period. Okay, we back to our $100 investment. What we have after 2 years, assuming the interest rate does not change. Okay, 110 times by 0.10 equal to 11. Total 110 plus 11 equal to 1 to 1. 1 to 1 is the future value of $100 in 2 years at 10%. We can see question example 1. If 3,000 ringgit is invested for 4 years at 9% compounded annually, how much is earned after 4 years? Okay, we can see the solution given P, R, N, and R. Okay, so you just fill using the formula, and the final answer is 4234.74 ringgit. Okay, let's move on to example number 2. Find the accumulated amount A if $4,000 is invested at 3% for 6 years compounded monthly. Okay, this solution is different from previous example. We must multiply first with month, which is 12 months. So you can see the example in this slide. So the final answer is 4787.79.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HAFIZ bin SUPIAN, matric number 1202400. Okay, today I would like to present about present value. What is present value? Present value refers to the amount required now to reach the desired future value. The formula for present value is P equal to S1 plus I to the power of negative N. I is equal R over M, and N is equal to MT. 1 plus I to the power of negative N is called discounting. Okay, for the next slide is example of present value. Jason invested a sum of money 10 years ago in an account that paid interest rate of 8% compounded monthly. His investment has grown to 5,682.28. How much was his original investment? Given T is equal to 10, R is equal to 0.08, M equal to 12, and S is equal to 5682.28. So I equal to R over M. R is 0.08 over M. M is 12, and N is equal to MT, which is 12 times 10 equal to 120. So the P is 5682.28 times by 1 plus 0.08 over 12 to the power of negative 120. So the answer is 2560. We go to the next slide, which is single payment trust fund. A trust fund for child education is being set up by a single payment, so that at the end of 15 years there will be 50,000. If the fund earns interest at the rate of 7% compounded semi-annually, how much money should be paid into the fund? So the solution, we want the present value of 50,000 due in 15 years. So we get with S equal to 50,000, R equal to 0.07 over 2, D equal to 0.035, and N equal to 15 times 2, which is the answer is 30. We have P equal to 50,000 times by 1.035 to the power of negative 30, and the answer is 17.813.92. So 17,813.92 should be paid into the fund. Next is equation of value. Suppose that Mr. Smith or Mr. John to sum of money, 10,000 due in 2 years and 600 due in 5 years. If Mr. Smith wishes to pay off the total debt now by a single payment, how much should the payment be? Assume an interest rate of 8% compounded quarterly. The single payment as due now must be such that it would grow and eventually pay off the debts when they are due. That is, it must equal the sum of the present value of future payment. As shown in the timeline of figure 5.1, we have X equal to 1,000 times 0.12 to the power of negative 8 plus 600 times by 1.02 to the power of negative 20. This equation is called an equation of value. We find that X equal to 1,257.27. As I explained before, this equation of value, we will go to the example for equation of value. A debt of 3,000 due in 6 years from now is instead to be paid off by 3 payments, 500 now, 1,500 in 3 years, and a final payment at the end of 5 years. What would this payment be if an interest rate of 6% compounded annually is assumed? Solution: let X be the final payment due in 5 years. For computational convenience, we will set up an equation of value to represent the situation at the end of that time. For in that way, the coefficient of X will be 1, as seen in the figure 5.3. Notice that at year 5, we compute the future values of 500 and 1,500, and the present value of 3,000. The equation of value is 500 times 1.06 to the power of 5 plus 1,500 times 1.06 to the power of 2 plus X equal to 3,000 times 1.06 to the power of 1. X equal to 3,000 times 0.16 to the power of negative 1. 500 times 0.16 to the power of 5 1500 times 1.06 to the power of 2, and we will get the answer 475.68. Okay, comparing investment. Suppose that you had the opportunity of investing 5,000 in a business such that the value of the investment after 5 years would be 6,300. On the other hand, you could instead put the 5,000 in a savings account that pays 6% compounded semi-annually. Which investment is better? Solution, let us consider the value of each investment at the end of 5 years. At that time, the business investment would have a value of 6,300, while the saving account would have a value of money will have a value of 5,000 times 1.03 to the power of 10 equal to 6,719.58. Clearly, the better choice is putting the money in the saving account. Next slide, net present value. If an initial investment will bring in payments at future time, the payments are called cash flow. If the net present value is greater than 0, then the investment is profitable. If net present value is less than 0, the investment is not profitable. Example, suppose that you can invest 20,000 in a business that guarantee you cash flows at the end of years 2, 3, and 5 as indicated in the table to the left. Assume as interest rate of 7% compounded annually and find the net present value of the cash flow. As we can see, year 2 the cash flow is 10,000, year 3 the cash flow is 8,000, and year 5 the cash flow is 6,000. Okay, we continue from the slide before this. Solution, subtracting the initial investment from the sum of the present value of the cash flow gives the net present value is 10,000 times by 1.07 to the power of negative 2 plus 8,000 times 1.07 to the power of negative 3 plus 6,000 times 1.07 to the power of negative 5 and minus 20,000. So the answer we get is 457.31. Since the net profit value is less than 0, the business venture is not profitable if one consider the time value of money. It would be better to invest 20,000 in a bank paying 7% since the venture is equivalent to investing only 20,000 minus 457.31 equal to 19,542.69.
Okay, now let's move to the next part, which is annuity. Annuity is sequence of payments made at regular time intervals. Okay, the first is ordinary simple annuity, which is the payment are made at the end of each payment period and the payment and compounding frequencies are equal. The simple annuity due is the payment are made at the beginning of each payment period and the payment and compounding frequencies are equal. Okay, now let's look at the formula for future value ordinary annuity. So the S is the future value of an annuity stream. R is dollar amount of each annuity payment. R is interest rate, and N is the number of period in which payment will be made. Let's take a look for the first example. Find the amount of an ordinary annuity of 36 monthly payments of $250 that earns interest at the rate of 9% per year compounded monthly. Solution given: N is 36, R is 250 and I is 0.09 divided by 12. From the all information given and applies to the formula as I stated before, and then we got the final answer, which is $10,288.80. Now let's take a look for the formula for present value. Ordinary simple annuity. As you can see the formula, the present value, which is P, of an annuity of payment of $R each, paid at the end of each investment period into an account that earn interest at the rate of R per period is. Okay, now let's take a look for the next example. Emma's parent loaned her some money to buy a car that required that she pay $150 per month for 60 months, which interest charged at 2% per year compounded monthly on the unpaid balance. What was the original amount that Emma borrowed? The solution given: R is 150, N is 60 and I is 0.02 divided by 12. And then from the information, all the information given, and we apply to the formula, and then we got the final answer, which is 8,557 and 85 cents. Simple annuity due. As you can see the formula, the future value, which is S, of an annuity due of payment of $R each, paid at the beginning of each investment period into an account that earns interest of the rate .
Now, simple interest. Simple interest is a quick and easy method of calculating the interest charged on a loan. Simple interest is determined by multiplying the daily interest rate by the principal by the number of the days that elapse between the payment. The formula for simple interest. Simple interest equal to P times I times N. P is the principal, which is the amount of payment. I the interest, which is the interest rate, and the N is the period or the time. Now the example. For example, say a student obtained a simple interest loan to pay 1 year of college tuition, which costs 80,000, and the annual interest on the loan is 6%. The student repays the loan over 3 years. The amount of simple interest paid is, so we will use all the data in the question, which is 80,000 will be the principal, 0.06 or 6% will be the interest rate, and 3 will be the period or the year. This is the amount of the interest, which is 3,240. So the total amount paid by the student, we will plus with the principal, which is 18,000. So the total amount will be paid is 21,240. Now is compound interest. Compound interest or compounding interest is the interest on a loan or deposit calculated based on both the initial principal and the accumulated interest from previous period. Compound interest can be thought of as interest on interest, and it will make a sum grow at a faster rate than simple interest, which is calculated only on the principal amount. This is the formula of compound interest, which is S is the compound amount, P is the principal, R annual interest rate, N is the number of compounding period. Example 1. Compute the compound amount when 1000 is invested for 5 years at the nominal rate 8% compounded quarterly. So, we will using the formula for the solution. S equal to 1000 bracket 1 plus 0.08, which is the rate, and then divided by the 4, and then we times 5 with 4, and then we solve the solution and we will get 1485 and 95 cents. This is the total amount of interest plus with the principal. Example 2. Suppose that 500 amounted to 588 and 38 cents in a saving account after 3 years. If interest was compounded semi-annually, find the nominal rate of interest. So this question asks us to find the interest rate. So we will use all the data and put in the formula except for the interest rate, and then we solve the formula until we get the amount of interest rate, which is 2.75%. So this is the answer.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adib bin Muhammad Zaki. I will gonna present the amortization part. So what is amortization? Amortization refers to the process of writing down the value of something, usually a loan or intangible asset. So fundamentally, amortization is like a depreciation, but it was intangible asset or loan. So amortization is the practice of spreading an intangible asset cost over that asset useful life. Alright, before we go further into the details, we have to know the variable in amortization. Firstly, A, which is the principal, R, interest rate, N, number of period, BR, periodic payment, and K, the number of the terms. Now, we are going to look at the amortization formula. First is the periodic payment. For the periodic payment, A, which is the principal, times with the R divided by 1 minus in a bracket 1 plus R to the power of negative N. And then here is the principal outstanding at the beginning of case period, and then last but not least, total interest paid and big R minus principal A. Now let's look at the periodic payment example. The formula is used to determine the periodic payment needed to be made by the entity to pay back according to the amortization condition. For example, a person amortizes a loan of 100,000 for a new car by obtaining a 20-year mortgage of annual rate of 7.5 and compounded monthly. So
how much is the monthly payment for the loan the person made? Okay, after determining the variable of the amortization and we put it in the formula, we get RM 805.95, which is the monthly payment. Now let's look at the principal outstanding at the beginning of terms period. Based on the example above or the previous example, we are going to see how much is the principal remaining after the 5 years. And then after determining the variable of the question, and then we put it into the formula, the principal remaining after the 5 years, we got RM 86,901.75 cents from 100,000. Last but not least, the total interest paid. So by using this formula and R minus A, we are going to know how much is the total interest paid at a certain period. And by using the previous example, we are going to calculate the total interest charges along the amortization. Then we determine the variable, we put it into the formula, and we get RM 93,341 for the total interest charges.